So I've been saying I'm not really creating content unless I have something to say. I'm not creating content just to create content. So I woke up having a little scroll on the phone, drinking some coffee. Daily meditation, coming to grips with being awake. Um, the science does not change. That's what I'm coming to. That's what I'm going to reiterate. When they say the science changed, they are speaking incorrectly. The science is a term referring to the studies, the results of the studies, the interpretation of the studies, the data related to the studies, meta analyses of multiple studies. What he's referring to is more specifically in this instance, anytime anybody says that, there's a couple of things. Viruses will not change that radically from strain to strain, and even over the course of the entire thing, they don't change a whole lot. They usually just get weaker. My point in mentioning this is that random new viruses don't just pop up. They evolve in other places where they're not communicable to us, and then sometimes happen to have a strain that mutates in a way that can transmit to us. Over the course of straining through becoming survivable and the point of evolution is not survival of the fittest. The point of evolution is natural selection. Whatever happens to survive gets repeated, and that's another thing people don't think about properly. They mistake. It never gets explained right. So, over the course of this microevolution of straining, it's not going to go from being it's like cats don't give birth to dogs. Dogs don't give birth to cats. You may have some feline traits that can be bred over a long period of time to get a cat-like dog or a dog-like cat. But you're not going to have a dog just give birth to a cat. Viruses are the same way. Mutations in nature most of the time do not survive. Science is a method of observation. That is all it is. Science means study. So, or to observe, but to study. Good science takes notes, is consistent in those notes. That is why there is a lot of collegiate training in scientific fields. A lot of it is just them practicing the method, the scientific method, which is to take detailed, consistent notes throughout the entire process and make it so that everything is as consistent and uniform as possible as far as the way that you notated everything to make the information as accessible as possible for analysis and for repetition. You put out the steps of an experiment. The whole thing is that you make an educated guess is a hypothesis. What they mean by educated guess is that somebody in the field who has knowledge of that which is being studied says, well, if this, then what about this? And is there a way to test for that? And then they try and scientifically back from existing knowledge, this is your educated guess, how it would or could or should work, and perform, you design an experiment, you find some way to render a result that if it's this, you get this, and if it's something else, then you know you're wrong. And then you do this, and you perform this experiment with as many data points as possible, which means test subjects or poll participants, or you want to see how a particular type of fertilization works on flowers, and you'll have a X number of flower plants that you planted, how many of them sprouted, how many of them survived for how long until the last was gone, and you have a control group where you have half of them are not fertilized and half of them you're testing this fertilizer on or whatever you're doing. That's how you do a study. The more data points, the bigger the data pool, the better. That way you can rule out mathematical anomalies, or just sometimes you'll have clumping in populations where maybe there's a lot in this one area and normally it's not the case. If you take test subjects from a different area and see if there's a similar clumping or whatever in the data, there's all kinds of ways. That's science. That's the science. That is the analysis of the information after experiments have been conducted which either prove or disprove the hypothesis. And it's made to be repeatable. That's what peer review means. That means that if you're doing your job right and you're taking the right notes and you're notating your experiment, somebody else can read your paper, they can do what you did, recreate the experiment, and probably, if you're correct, get the same results. Or get a similar result, but in a way that's slightly different, that shows something that maybe you missed, and then they can write their own paper about it. Unless the initial studies are cooked up to begin with, fake. More recent studies indicating the science changed. If you're getting opposite results of what the initial studies were saying, you have to question the initial studies. You have to look at their methodology. You have to make sure that their sample size is good, that they didn't, edit or cherry pick the data so that their result was irrefutable in their paper. People do this. It's a human thing. So it's done for profit oftentimes. So if you had decades of peer-reviewed, fairly established science indicating one thing, and now the studies are saying something else, you have to question both ends. But you can only question the historical peer review so much because it has remained so for so long. So unless there's been corruption keeping bad science in place in other areas for a long time, you conspiracy theorists, you'd have to, that's what they call people that suggest such things. Unless there's something like that going on, then you have to really question the new science. As political and profit-driven as everything has become, you have to question everyone's motives. So, the science changed. What exactly changed? No, the I've said this before myself. The dude that was on Timcast last night said the same thing. The science didn't change. Your understanding of the science changed. Your understanding of the results, more specifically, is what changed. Because in a field like that, you're talking about living molecules. You're not talking about as complex a creature as, say, a human or even a dog or even a lizard. Something that to us is super ultra tiny, that within the microscopic world of it's right in the middle. This is an extremely large, whatever, it's like, it's not even a cell, but it's several proteins which are made up of molecules, chains of molecules. They're all put together like Legos. And this is a type of those. They've understood how these things work. They are somewhat simple because they have a basic replication process. They have a method in which they insert, they replicate, and then they spread. And different viruses affect different types of tissue, which means different areas of the body that may be affected differently. And in the case of this one, it mostly affects your chest and your sinuses. Although it spreads throughout your entire body. So you got someone who is an immunologist, who is this top honcho, and what he's saying is the science changed. Obviously, we all already know that the narrative agenda shifted. And so then they started telling people differently. So have you ever noticed people trying to use the medical tyranny as justification? It's for the betterment, it's for the good. Doesn't that sound a lot like legislating morality? Remember how we used to have arguments about reasons why you shouldn't use a biblical reason for, say, being anti-abortion? Even if that's what your motivation is, if you want to make it illegal, you have to find a non-biblical justification for it, because separation of church and state. No laws respecting an establishment or religion. Even though they don't follow that anyway, but rather than make it worse, the whole point is, like, using the law. And even more so, what you've got is in this new type, it's not even legislating morality, because the legislators aren't the ones making the laws. It's the executive and the inverted totalitarian aspects as well. But this is all executive decree, if you notice. The governors decide, their state legislatures are not writing lockdown bills. They're not the ones setting the rules, so they're not legislating morality, but they are making a moral decree, I suppose, or a decree with some sort of self-perceived moral mandate. But then they say the science changed, and we're going by science for this morality. Science is the new morality. The understanding of the result of the process of science, being careful there, has not changed either. Just from looking at the family, the type, the characteristics of the others, I personally was able to predict what it was going to do based on what we'd already seen. And I'm not a doctor. So either we've got issues with dogmatic thinking and a lack of critical thinking in the scientific community, which is terrifying, or there is a lot of corruption in the localities of science and medicine because people everywhere are playing along. I know in some places there are some doctors who aren't, but I also, to be fair, to be honest and objective about it, I don't go to the hospital and haven't been to a doctor in a very, very long time, so I have no idea what a conversation like that would be like around here. But from past experiences, that a lot of them are there to collect a paycheck. And we know profit was a part of the whole thing on so many fronts. So when they say the science changed, what they're really saying is we were wrong about something without saying it. Tell me you're wrong without telling me you're wrong. But the science is just a process of observation. I've already been over that. Now, people will refer to the knowledge base as the science. The knowledge base hasn't particularly changed either. They have had attempts to inject some bad science and false information into the knowledge base, but the peer review process actually weeded that out. It did its job. So, an example of that is the only study that came out that had any conclusive claim in the affirmative to masks working. And see, this is the thing. It doesn't matter where. Okay, it matters in what field a study comes out. If an astrophysicist tries to do a medical paper without also having a medical background, if they're purely theoretical science, they're basically a mathematician. They need to have like actual medical experts in on their study, or else their study is pointless. But if one type of doctor has a question about something that other types of doctors use a similar thing and does a study, that's valid. Or if people who don't have the funding in a community of professionals and practitioners were to, sorry, I had a phone call. If they were to request a study that they don't have funding for, is what I'm getting at, and request the community to of the the people that have the grants to be like, hey, why don't we have this? Can we do this? Originally, the only studies or the requests for studies, there were a number of open letters and what you could call philosophical exercises in why it's important to look into this. Their arguments for justification was the dental community asking about masks. What really is the point? And the best that they were able to come to was it's a drool catcher for surgery. It's so that if you're focused on something and your mouth is open and you're breathing and you're trying to be careful on something and you don't want to dribble. So you have that. So before Dan Mask 19 came out, that was the extent, was some requests for studies on the actual effectiveness in preventing any kind of disease transmission of masks. Because prior to that, all of the studies kept coming up inconclusive. What that basically means is that there could be a lot of people that had worn a mask but got sick, and there were other people that didn't wear a mask and didn't get sick, and vice versa in some numbers. And rather than to say they don't do anything, you can say we can't tell if there were other factors. And there are other studies about the outside of the mask, the part that when you breathe, air goes through, having been Petri tested. And this is pre-existing science. This stuff didn't change. What they call ILI, influenza-like illness, they have a way of experimenting and testing for the spread of airborne respiratory viruses in general, because they have a particular way they behave. And so when they would say, we don't really know, this is a novel thing, it's a whatever, by the time they were saying this in public, the genome had already been extrapolated. Other countries that had CRISPR machines were able to break apart what this thing was. They already knew at that time that it was of the beta family. They already knew which spike protein. All of this information was known, which means that everything that they knew about the other types of the virus was probably going to be applicable. And that was the prediction that I made. So if this supposed expert keeps saying things like this, I mean, you've already heard him basically say, I am the science. If you're questioning the science, you're questioning me. Yes, I am questioning you, sir. Yes, I am questioning you, sir. Are you calling me a liar? Yeah. Yeah, you're lying. You're lying. That's what it is. That right there. That's what it is. To say the science has changed like that is a liar saying, well, I guess we were wrong about some stuff, without saying it. The method shouldn't change, because then the results would change in an inaccurate way. If you're trying to actually be objective and find knowledge and gain information, seek truth, you have to abide by principles of logic, you have to abide by principles of science in determining things. And anything else is dishonest, to say the least. I'm going to cut it short there. I'm going to find out what was up with that number, because I think that might have been work related.